For our next example 2, we're going to be evaluating cotangent of 345 degrees. And we're going to be using our enhanced unit circle. Now, you might be thinking, how can we figure out cotangent if it's not even on our enhanced unit circle? All we have is y over x, which is tangent. Well, fortunately, we know that cotangent is just flipped of y over x. Cotangent's x over y. So we can just do the reciprocal of 2 minus square root of 3, i.e. 1 over 2 minus square root of 3, and simplify that. I think that's easier than trying to remember all the cotangent values on this enhanced unit circle. I certainly don't know them for the original unit circle, and you don't need to if you understand that reciprocal identity. So, we're going to follow the same steps we did in example 1 to figure out cotangent of 345. First step is to locate the angle on the unit circle. Our enhanced unit circle, that is. So where is 345 on this circle? Well, 345 is right here. It's 15 degrees from the x-axis. And that already gives you a hint that the 15 degrees in the first quadrant is going to be its corresponding angle because they're both close to the x-axis. So that's it for step one. Let's go on to step 2, which we have already alluded to. Step 2 is to determine which axis it is closest to. Well, it's closest to the x-axis. So step 3 is to determine the sign of the trig value in that quadrant. So again, we said all students take calculus. Calculus represents the fourth quadrant. It goes first, second, third, fourth. So that means only cosine is positive in the fourth. And again, if you look at this, you can tell that at 345 we're below the x-axis. So we know it's going to be negative. Therefore, for step 3, we know that cotangent is going to be negative because only cosine is positive in the fourth. Don't be mistaken with that C. That C stands for cosine, not cotangent. Okay, next, for step 4, we're going to determine the corresponding angle in the first quadrant, which I've already alluded to again. But again, 345 corresponds to 15 on the unit circle because they're both closest to the x-axis. Here's our actual values. They're both closest to the x-axis, so 15 corresponds to 345. Okay, and here's where the steps, I think, kind of get easier. Okay, step 5 is to determine the trig value. So first of all, we actually don't know what cotangent of 15 is, right? But we do know what tangent of 15 is. It's 2 minus square root of 3. So I've already alluded to this, but cotangent is just going to be the reciprocal of that, 1 over 2 minus square root of 3. So to figure out cotangent of 15, we do the reciprocal of 2 minus square root of 3. So we're going to put 2 minus square root of 3 under 1, and then, which is just the same as y over x. Don't be confused by that. But again, you can tell because x over y is equal to 1 over y over x, so that's another way of proving it. Okay, so we have to simplify this because we can't have a radical in the bottom, which means we have to multiply by the conjugate of 2 minus square root of 3, which is 2 plus square root of 3. And we also have to do that to the top of the fraction. We know for the conjugate the two middle terms are going to cancel. We're going to get 4 minus 3, which is 1 on the bottom. And on the top it just becomes 2 plus square root of 3 because we multiplied 1 by 2 plus square root of 3, which just becomes 2 plus square root of 3. So all that to say, and I should definitely label this, cotangent of 15 degrees is actually just 2 plus square root of 3, which is pretty crazy, right? I mean, look how similar it looks to tangent. Instead of 2 minus square root of 3, it's just 2 plus square root of 3. Pretty crazy, which hints at the fact that cotangent of 75 might be 2 minus square root of 3, right? Just the reciprocal of that. Now, it can't be for sure, but yeah, actually it is, because they're just, they are cofunction identities. So yeah, cotangent of 75 would be 2 minus square root of 3. So that's actually an easy way to remember cotangent, is just to know that it's going to be that opposite sign in the middle of the 2 and the radical 3. So again, cotangent of 15 is 2 plus square root of 3. Okay, so there we have it written out. Now, we were originally trying to figure out cotangent of 345, and since it's in the fourth quadrant, we're just going to take our cotangent of 15 and multiply it by negative 1. So step 6, multiply the corresponding sign from step 3. So just multiply cotangent of 15 by negative 1, and voila. This is actually going to be my answer. Cotangent of 345 is negative parentheses 2 plus the square root of 3. Again, you don't need to do any simplification for that. However, for step 7, you want to double check that you cannot simplify that expression and be done with the problem. So final answer for this one, cotangent of 345 is equal to negative quantity 2 plus radical 3, and if you look at my original enhanced unit circle, you will see that we have tangent is square root of 3 minus 2. And we can see that our actual answer is a variation of it. It's not exactly the same, and you don't just change the sign to the plus. So yes, that did work for the first quadrant, but not for our answer. So tangent is square root of 3 minus 2 for 345. But cotangent is a negative quantity 2 plus square root of 3. So both of these end up becoming negative. So be careful about that. Don't invent any rules that don't exist. And make sure you follow all of these 7 steps, and you're going to get the right answer every time. That's it for cotangent of 345. If you have any other questions about it, let me know.